In this lecture, we will be discussing about the series connection of resistors and voltage division rule. So first of all, let us see the specialities of a series resistive circuit. Consider a series circuit in which three resistances are connected in series. So suppose there are three resistances R1, R2 and R3 connected in series. So resistors can be connected in series when they are connected end to end. A series connection is obtained when resistors are connected end to end. That means at the end of resistor R1, resistor R2 is connected, and at the end of R2, R3 is connected. Likewise, a series circuit is obtained by connecting resistors end to end. So we have considered three resistors R1, R2 and R3 which are connected in series. And this series combination is connected across a voltage source V. And let I be the current flowing through the circuit. So V is the total voltage applied across this series combination and I is the current flowing through the circuit. So from this diagram itself, it is evident that this current I will flow through all the resistors R1, R2 and R3. So it is clear from the diagram itself. This current will circulate like this. Okay. So that is current flowing through all the resistors is the same. Same current I flows through all the resistors. So this is one of the important specialities of a series circuit. In a series circuit, current flowing through all the resistors will be the same. So current is same in all the components of a series circuit. And let V1 be the voltage appearing across resistance R1, V2 be the voltage appearing across R2 and V3 be the voltage appearing across resistor R3. So here even if we have a single voltage source V, different voltages will appear across the resistors. We know when a current is flowing through a resistor or a conductor, a potential difference will appear across the terminals of that conductor. So across each of the resistors there will be a potential difference or voltage, and they are marked as V1, V2 and V3. So now this total voltage V is dividing into 3 and appearing across each of the resistors. So we can write the total voltage V is equal to V1 plus V2 plus V3. Okay, total voltage is equal to V1 plus V2 plus V3. And according to Ohm's law, we know the equation for voltage across a conductor, which is equal to current through the conductor into resistance of the conductor. So this is the Ohm's law equation. V is equal to IR. So here this V denotes the total voltage applied across this circuit. So that V can be represented as total current flowing through the circuit into total resistance of this series circuit, which is denoted as RT. So I into RT denotes the total voltage appearing across this circuit, which is equal to V1, which is the voltage across resistor R1. So which is also having the equation I into R. So V1 is equal to current flowing through R1, which is also I into resistance, that is R1. Similarly, V2 is current flowing through that resistor, that is I into resistance of that particular component R2. Similarly, V3 is I into R3. So this equation can be written as I into RT is equal to, I am taking I as common outside, into R1 plus R2 plus R3. Okay. So here this I and this I gets cancelled, and the resulting equation is the total resistance of this series circuit is equal to R1 plus R2 plus R3. So that means in a series circuit, the total resistance or the equivalent resistance will be equal to the sum of individual resistances. Here total resistance is R1 plus R2 plus R3. That is, in a series resistive circuit, the equivalent resistance will be the sum of individual resistances. So always keep this point in mind. For series connected circuits, total resistance is the sum of individual resistances. So now let us move on to the voltage division rule. So here in this case of the series circuit, we have already seen that even if we are applying a voltage V across this circuit, we get different voltage levels V1, V2 and V3 across the various resistors. The current through all the resistors is the same, but voltage appearing across them may or may not be the same. That depends on the value of these resistances, right? V1 is I into R1, V2 is I into R2 and V3 is I into R3. So if the value of R1, R2 and R3 are same, these voltages will be same. But if we are using different resistors, different voltage will appear across each of the components. That means in a series circuit, we will get different voltage levels from a single voltage source. We are using a voltage source or a battery having a voltage V, but we will get different voltage levels across the different resistors. And voltage division rule enables us to calculate the voltage across each of the components in a series connected circuit. So voltage division rule is to calculate the voltage across each of the components in a series circuit. Okay, so how will we calculate this voltage? As we have said, V1 is I into R1, V2 is I into R2 and V3 is I into R3. That means if we know the value of if we know the value of I, we can calculate V1, V2 and V3. If we know the value of I and then the value of resistors, we can calculate V1 as I into R1, V2 as I into R2 and V3 as I into R3. So if current is known, we can easily calculate these voltages. But what voltage division rule enables us is that it helps us to calculate the voltage across each of the components in this series circuit without knowing the value of current. Without knowing the value of current. Okay. So even if we don't know this value of current, we can calculate the voltage appearing across each of these resistors by applying the voltage division rule. So now let us see how this voltage division rule works. So now consider a series circuit, same as in the previous case. A series circuit comprising of three resistors, R1, R2 and R3. So this is R1, this is R2 and this is R3. And we are applying a total voltage of V across this series combination of resistors, and I is the current flowing through these resistors. V1 is the voltage across R1, V2 is the voltage across R2 and V3 is the voltage across R3. Okay. Now, by Ohm's law, we know V is equal to I into R, or the total voltage applied across this circuit, V is equal to total current flowing through the circuit, that is I, into total resistance of the circuit, that is RT. And we know how to calculate this total resistance. In a series circuit, total resistance will be the sum of individual resistances. So we have V is equal to I into RT, and from here we can write the equation for current I. So I will be equal to V divided by RT. Okay, so we have the equation for current in terms of the applied voltage and total resistance. Now let us calculate the voltage across each of the components. So voltage across R1. First let us calculate voltage across R1. Voltage across R1 will be equal to V is equal to I into R according to Ohm's law. So current flowing through R1 into resistance, that is R1. Okay, which is equal to. So we have the equation for current in terms of applied voltage and total resistance. Substitute this equation for current. So this becomes V divided by RT into R1. Okay. Now let us calculate voltage across resistor R2. So according to Ohm's law, V is equal to IR. So for R2, voltage is equal to I into R2, which is equal to I is V by RT. V divided by RT into R2. Okay. And then voltage across R3. Will be equal to I into R3. I is again V by RT into R3. So these are the equations for the voltage across each of the individual resistors. So we can write a general equation from these three equations. If we examine these three equations, we can reach at a general equation for calculating the voltage across each of the resistors. See, voltage across the resistor R1 is total voltage divided by total resistance into that resistance R1. Voltage across R2 is total voltage divided by total resistance into that resistance R2. And voltage across R3 is total voltage divided by total resistance into that corresponding resistance R3. Or in general, according to voltage division rule, voltage across a resistor equal to total voltage by total resistance into the corresponding resistance. So this is the equation for voltage division rule. So this is a very important rule related to series circuits. It enables us to calculate the voltage across each of the components in a series circuit without knowing the value of current, without the need to know the value of current flowing through those components. So voltage across a resistor equal to total voltage applied across the series combination divided by total resistance of that series circuit into the value of that resistance across which we are calculating the voltage.